Hi, I'm Julie Rich, and I study how cells achieve their shape. Specifically, I study fission yeast, which is a single-celled organism that is shaped like a cylinder, or more like a Beats pill speaker. So it's important to understand a cell's structure because it ultimately determines the cell's function. A cell must determine the proper site to grow right after division so that it can achieve its proper structure. I study when, where, and how much these cells grow. You could say that I study a microscopic version of football, but it has very different rules, and I don't have a complete rule book. I want you to imagine that the ends of one of these cells are like the end zones on a football field, except the end zones don't ever swap teams. Growth only occurs at the cell ends, much like you can only score a touchdown in the end zone and you can't score it offsides. The cell contains a complex network of transportation machinery that moves materials from one end of the cell to the other, like players on a football field move the football. My advisor published a paper showing that the ends are in competition with each other. Each one is struggling to grow, but only one can have the cellular equivalent of a football at a time. So if you sit back in your recliner with a bowl of popcorn to watch a nail-biting game of fission yeast football, you will notice something very clear. The old end, or the end that existed in the previous generation, is always the first end to grow after division. I've marked the old end with the letters OE up above. So think of the old end as if it is the Volunteers' end zone in the first half of the game, and the Volunteers don't know they're playing a football game yet. We're familiar with this scenario. It's like the other team has no competition. They can score at the old end zone with very little resistance. Eventually, though, the Volunteers realize that they're playing a football game, and they muster up their resolve and manage to get out there and make a glorious comeback. The rest of a cell's life, growth oscillates between the two ends of the cell. The football oscillates between the two ends of the field, much like the last few minutes of the UGA game. Now, this is the most interesting part. At the end of the game, both teams meet in the middle of the field and cut it in half. This is cell division. The previous middle of the field becomes the two new ends of the two new cells, while the old end zones become the old ends of the two new cells, as depicted up on the screen. When growth or gameplay resumes after division, both of the old end zones initially win the competition for the first half of the game. My research so far has led me to hypothesize that the old end retains a memory of growth that enables it to win the competition immediately after cell division. In our analogy, the old end remembers that it's playing a football game, and the new end doesn't know what's happening quite yet. My goal is to find out what makes the old end initially dominant over the new end for growth. I believe that the factor that imparts the memory of growth does so by getting a hold of the football and keeping it close to the old end during division. This may sound like cheating, but it makes it really easy to get the football into the end zone after division completes. So this gives the old end an advantage in the competition for growth. Now that I've established the presence of a memory of growth that imparts old end dominance, my Heisman will be awarded if I can unmask the player known as the memory of growth